Have you ever wondered what a supernova is? Let's start at the very beginning, not of the universe but of a star. Picture this: a vast, seemingly infinite cloud of dust and gas swirling in the cosmos. We call this a nebula. It's not just an ordinary cloud but a cradle of creation, a nursery for stars. As gravity pulls the particles in this nebula together, a clump begins to form, growing denser and hotter with each passing moment. The heart of this clump, a protostar, is where the magic happens. With the intensity of the heat and pressure, hydrogen atoms, the most abundant element in the universe, start to come together. This is no simple meeting of particles, it is a fusion, a dance of atomic proportions. Two hydrogen atoms join forces, becoming a helium atom. But this transformation doesn't happen without a cost. A tiny bit of mass is lost in the process, and as the great Einstein taught us, mass can be converted into energy. This energy, folks, is what makes a star shine. It bursts forth in the form of light and heat, illuminating the universe around it. Day and night, year after year, the star's radiance is a testament to the ongoing fusion at its core. Now, this process doesn't happen overnight. It takes millions, sometimes billions of years for a star to fully form. But once it does, it becomes a beacon in the darkness, a point of reference, a source of warmth and light. Every star you see in the night sky, every sun that warms a distant planet, every speck of light in the universe has undergone this incredible journey. From a humble clump of dust and gas in a nebula to a shining star, the birth of a star is truly a cosmic spectacle. So that's how a star is born, but what happens when a star dies? That's where supernovas come in. So, what happens when a star exhausts its nuclear fuel? It's a question that has fascinated humans for generations. You see, the life of a star is a delicate balance between the force of gravity pulling inwards and the pressure from nuclear fusion pushing outwards. As long as there's enough fuel for fusion, the star maintains its equilibrium. But what happens when the star runs out of fuel? It's a bit like the engine of a car running out of gas. Without fuel, the car can't move forward. Similarly, without fusion, a star can't resist the pull of its own gravity. When the nuclear fuel is depleted, the star starts to collapse under its own gravity. The core shrinks, and as it does, it gets hotter and denser. This increase in temperature and density ramps up the fusion process. It's like the star is trying to squeeze out every last bit of energy it can, a final hurrah before the inevitable. As the core continues to collapse, the fusion process becomes more intense, more desperate. The elements in the core start to fuse into heavier and heavier elements. Hydrogen becomes helium, helium becomes carbon, carbon becomes oxygen, and so on, in a process known as stellar nucleosynthesis. This process continues until the core starts to form iron. Now, iron is a special element in the life of a star. Unlike the elements before it, iron doesn't release energy when it's fused. Instead, it absorbs energy. This is a turning point for the star. The core, once the source of the star's energy, now becomes an energy sink. The star's struggle becomes more desperate. It's like a fire that's run out of wood and is now trying to burn the ashes. But the ashes, or in this case, the iron, won't burn. The star has exhausted its nuclear fuel and the end is near. When the core turns to iron, the star is on the brink of a cataclysmic event, a supernova. The stage is set for one of the most spectacular events in the universe, but that's a story for another time. So, what exactly is a supernova? Well, picture a cosmic fireworks display that outshines entire galaxies. That's a supernova. This phenomenon is a stellar explosion radiating with such immense light and energy that it briefly outshines an entire galaxy. At the heart of a supernova is the death of a star. Not just any star, but a star that is burned through its nuclear fuel and is on the brink of collapse. The core of the star, once a furnace of nuclear fusion, now struggles under its own weight. The gravity becomes so intense that the core starts to shrink, compressing itself into a tiny, dense point. As the core collapses, it sends shockwaves ripping through the outer layers of the star. These shockwaves cause the outer layers to explode outward in a cataclysmic event. This is the supernova, a powerful and bright stellar explosion that releases a phenomenal amount of light and energy. The light from a supernova is so intense that, for a brief period, it can outshine the combined light from all the stars in its host galaxy. This brilliant flash of light is visible across vast cosmic distances, making supernovas some of the most visible events in the universe. The energy released in a supernova is equally staggering. In a matter of seconds, a supernova can release more energy than our sun will produce over its entire 10 billion-year lifetime. This energy, in the form of light and heat, radiates out into space, illuminating the cosmos with the death throes of a star. A supernova is more than just a spectacular light show. It is a testament to the life and death of stars, the cosmic cycle of creation and destruction. It's a reminder of the incredible forces at work in the universe, forces that shape galaxies, create elements, and ultimately, give rise to life itself. But the story of a supernova doesn't end with the explosion. Indeed, the aftermath of a supernova is just as fascinating, and it's where we'll be heading next. What happens after a supernova explosion? Well, the aftermath of a supernova is no less than a cosmic spectacle. The explosion disperses elements that were formed within the star into the universe. Picture it like a grand cosmic recycling program, where the death of one star seeds the universe with the raw materials for the birth of others. During the star's lifetime, nuclear fusion in its core created elements like hydrogen, helium, and heavier elements up to iron. During the supernova explosion, even heavier elements are formed. Elements like gold, platinum, and uranium. These elements, mixed with the light elements, are flung across space by the force of the explosion. And it's these elements, these remnants of a star's life and death, that become the building blocks of new stars, new planets, and even life. Yes, you heard it right. The iron in your blood, the calcium in your bones, and the oxygen that fills your lungs were all once part of a star that lived and died billions of years ago. Just think about that for a moment. We are, quite literally, made of star stuff. But what about the core of the star, the heart that once pulsed with nuclear fusion? Well, it doesn't simply disappear. If the core is massive enough, it collapses under its own gravity to form a black hole, a region of space where gravity is so strong that nothing, not even light, can escape. If the core is less massive, it forms a neutron star, an incredibly dense object about the size of a city, but with a mass greater than that of our sun. And so the cycle continues. The death of one star leads to the birth of others, to new planets, and to the elements that make up the world around us and even our own bodies. It's a constant cycle of death and rebirth, destruction and creation, endings and beginnings. So, in a way, a supernova is a rebirth, a new beginning. Why should we care about supernovas, you might ask? Well, these celestial fireworks are not just spectacular to behold, but they also offer us a deeper understanding of our universe and its evolution. Consider this. Supernovas are the universe's recycling program in action. When a star explodes, it releases a vast amount of energy and matter into space. This stardust, rich in heavier elements like carbon, nitrogen, and oxygen, goes on to form new stars, planets, and even life. That's right, the very elements that make up our bodies, the air we breathe, and the ground we walk on were once part of a star that exploded in a supernova. We are quite literally made of stardust. But the importance of supernovas extends beyond their role in distributing elements throughout the universe. They also provide critical clues about the life cycle of stars. By studying supernovas, astronomers can gain insights into the processes that lead to the birth, evolution, and eventual death of stars. This helps us understand how our own sun will evolve, and what fate it might ultimately meet. Furthermore, supernovas contribute to our understanding of the universe's expansion. The brightness of a supernova can be used as a standard candle to measure cosmic distances. This has allowed scientists to determine that the universe is not only expanding but doing so at an accelerating rate, a discovery that earned the Nobel Prize in Physics in the year 2011. Lastly, while the chances are incredibly slim, supernovas could potentially impact life on Earth. A nearby supernova could bathe our planet in harmful radiation, leading to mass extinctions. While this may sound alarming, fear not. It also serves as a reminder of our connection to the cosmos and the delicate balance of forces that allow life to exist. So, the next time you look up at the night sky, remember the spectacular events that are taking place in the universe, like the death and rebirth of stars and supernovas.